this is the prototype version of our new prover counter. The faceplate isn't done yet, so this video helps show the operation of the counter using the switches on the front of it. Bottom right is the on-off switch, and the default screen is the version. This one is 1.0B, and the battery voltage, which needs to be above 4.5 for this for the encoders to work properly and for the counter to work. The counter will actually work at 3.3, but the encoders need at least 4.5 volts. So anyway, this is the enter button. This is what you use to scroll through the various screens and to accept changes like to the K-factor or to accept the proving run. And our first screen is the K-factor screen, which needs to be updated to give you an accurate flow rate. It does not affect the pulses. The pulses are what they are. But the K-factor helps us calculate the flow rate, which is based off of the gate input, not the pulse input, but either the pulse index, which is on the encoder, the prover switches, or this manual switch is also gives us a gate. So anyway, to edit the K-factor, you flip the program switch up, bottom left, and when you get to the point where you want to jump to the next digit, you hit the enter button. And when you're done, flip the program switch down. I got a simulator hooked up to this right now. It's just counting away. But this will do us this will gate the counter right here. And this button accepts the run. You see the flow rate is based on this guy right here. Now this switch here is your test prove switch. Down is wired to the Provalib switches or the master meter encoder. Right now we're just it's just only configured to do loop proving at this time. So when this thing is down, this is what starts and stops the counter, and this is just a manual override. This is just parallel to the gate switches. When this is up, it's looking at the encoder index pulse, which is once per revolution or once per 1,000 pulses. This simulator is doing 10,000 pulse trip. It's not based on an encoder. It's just a simulator that I built to test this thing. So the top counter is your pass, your one-way pass. The bottom counter is an accumulator. So normally you have two passes. This one's going to have 3. And it saves that run. You have to write it down at this point because I don't have the screens built yet to scroll through each run to get the pulses, and also we're going to have a link to your laptop to pull the runs up. So that's a half run. Round trip. When you're done, just reboot it. Okay, again, first screen is the K factor. Let's say you wanted to prove a 4-inch turbine, which would be like a 1450 something K factor. So let this scroll up to 0. This goes to 1. Oops, I missed it. Let's do a 2-inch. 2500. Same number of pulses off the simulator, but look at the flow rate now. It's 2,000 barrels an hour because of our 2500 K factor. It's before we were showing 5 something, and it's just a function of the time between the detector switches. And you can boot it as many times as you want. Put it back and prove. See, it saved our K factor from last time. So we want to go back to an 8400. Let this scroll up to 0. Run it up to 8. It'll automatically scroll 8. This will be 4. When we get to 4, we're going to turn the switch down. And we are now out of edit mode. This baby's screaming. Okay. Reboot it. It's got a new K factor.